So continuing, today I'm taking it through making subjects of the formula. How can you make subject of the formula? So making subject of the formula, making subjects of the formula. So we shall do some variety of examples and clarify how can we easily make subject of the formulas. So by the end of this, at least you should be able by all means to attempt such number of questions. So I will begin with example 1. So make the subject of the formula. For example, I can have 1. I'm given maybe A equals to a half BH. So for this case, they want us maybe to make B the subject of the formula. I'm putting B in brackets so that we are making B the subject of the formula. So for us to make the subject of the formula, ideally we're having this part of the equation and the right hand part of the equation. But how can we really make B the subject of the formula? We have to make B stand independently, meaning that on the right hand side we shall ideally remove all the elements which are known to B. So in the brackets they have indicated that we should make B the subject of the formula. So ideally our A equals to a half BH. Remember, this is an equation, this is over 1. I can easily just cross multiply such that I have 2 times A. I end up having 2A. This will give me B 1 times BH. Remember, we have multiplied 2 times this, then 1 times this. 2 is in the denominator and these are numerators, so 1 times the BH remain with the BH. Meaning the only way now for us to remove H is by dividing both sides by H. So I will simply divide both sides by H. Even this side I divide by H because they want us to make B the subject of the formula. So H cancels out with the H. So remain with B independent on each side. So we have made B the subject of the formula. Ideally our B will equal to 2A over H. So we have simply made B the subject of the formula. Then example 2, make H the subject of the formula. V equals to pi r squared H. So here they want us to make H the subject. So simply we shall also do the same. How shall we do? We shall make sure that H stands independent. So simply this one is very simple. What shall we do? We shall have to divide both sides by pi r squared on both sides so that H remain independent on each separate side. So I divide by pi r squared. Even this right hand side I do the same. I divide by pi r squared. I divide by pi r squared. So the pi r squared will cancel out. We shall remain our H independent on this side. So our H will be equivalent to V over pi r squared. So that is how we can make that the subject of the formula. Then let us see 3. Maybe make here we are going to make B the subject, maybe having 2B plus C equals to 13. So make B the subject of the formula. So this is also quite simple, only that we shall have to first remove C. Since C is a positive, when it crosses the cosine becomes a negative. So we shall have 2B equaling to 13 minus C. In other words, our C has crossed the equal sign. In other words, it says this C minus C, when you subtract C both sides. So C has crossed the equal sign, it has become a negative. So what next? We shall divide both sides by 2. Even here I'll have to divide this side by 2. So we shall have 2 cancelling out with 2, remain with our B, giving us 13 minus C over 2. So simply making subject of the formula, you make sure that you make that term they have told you to stand independent on its own side. So let us have another example and we see how we can go about it. So let us have another example. For we have R equals to PV. R equals to PV over T. So here they want us to make V the subject of the formula. Simply we shall follow the same procedure. Here we shall have to cross multiply. I end up by having RT equals to PV. So making V the subject of the formula, I'll have to divide both sides by P. Even here I'll divide by P so that our V remains the subject of the formula. So this cancelling out with this, I'll have V. So this is the V equating to RT over P. So this is the same. I'll just put what was this side on the right. So what was on the left, I just put it this side. So simply that's how we make the subject of the formula. We make sure the term given to you, you make sure it stands independent on its own side. So let us have also this, maybe our C equals to 5 over 9 into F minus 32. They tell you maybe in this case make F the subject of the formula. They want us to make F the subject of the formula. By all means you shall see that F has to be independent, and so this time round I can multiply both. This is number 5, yeah? So I can just try to remove that 5 over 9. How can I remove that 5 over 9? You remember I want to make, this is multiplication in between. So for me to remove this, to separate this, I have to either cross multiply, or I can just do it at once and I multiply both sides. I have to remove this 5 over 9. How can I do it, remove it, this 5 over 9 at once? I'll just get the reciprocal of 5 over 9. I multiply it both sides. How? I'll just say the reciprocal of 5 over 9 is 9 over 5 times C. I multiply the reciprocal both sides. Even here I multiply by 9 over 5 times 5 over 9 into F minus 32. So that this cancels out with this 5 with that. So here I remain with ideally 9C over 5, which will give me F minus 32. So 32 comes this side, it becomes a positive. So I'll have 9C over 5. 9C over 5 plus the 32. This will give me my F as the subject. So therefore our F will be equivalent to 9C over 5 plus the 32. So I've made here F the subject of the S the subject of the formula. So let us also look at another example where they tell us to make V the subject of the formula, and hence find the value of V when those terms are given. So this time round, example 6, they want us to make V the subject of the formula given the expression 1 over F equals to 1 over U plus 1 over V. Then hence we shall make what? V the subject of the shall make V the subject of the formula. So here we shall make V. What is indicated in bracket is what is required to be made the subject of the formula. Then hence they tell us hence find V when our U is given as 10. Want us to find V when U is given as 10 and F as 8. So simply looking at this, what we are given here, look at the denominator. We shall find simply the LCM in the denominator. So the LCM will just simply be the multiplication of all those members in the denominator. So So the LCM will be u times b times f. So the LCM, in other words, it is UVF. So what we shall do, we shall multiply all sides by the LC, all sides by the LCM, each individual by the LCM. So alternative, some other person can do it differently. So mathematics, there are many methods, but will lead us to one answer always. So for this case, I would decide to just multiply all sides throughout by the LCM, each individual by the LCM. Remember, we said our LCM was UVF, so I'll multiply it throughout by that LCM. So I'll get my 1 over f times UVF, which is okay, over 1, this equals to 1 over u. I also multiply it by UVF plus 1 over v. I also multiply it by UVF. So ideally the f here cancels out, u here cancels out, v cancels out. So shall ideally have here uv equaling to 1 times vf, which is vf plus c. V has gone, here remain with the u f, but the question required us to make v the subject of the formula. But here we ideally see that there are two v's. So in other words, we have to bring those two terms containing the v together so that we factorize it out. So I'll just have my uv here. This crosses the equal sign, becomes a negative, minus vf equals to our uf. So from there, I'll just have to factorize out this v, which is in common. So I pull the v out, I remain here with the u, then minus, then I remain here with the f, which will equal to my uf. So from there, I'll have to divide both sides by u minus f. So I will say v into u minus f divided by u minus f, okay, equals to uf. I also divide this side by u minus f. So the u minus f goes away this side. We shall ideally remain with the v as the subject of the formula. So our v, from what we had here, our v will equal to uf over u minus f. So our v will equal to uf over u minus f. So they are told us to substitute in our u. Our u from this question was given as 10 and f was given as 8. So our u is 10 and our f was given as 8. So u is 10 times f, which is 8, over u, which is 10, minus f, which is 8. So we have ideally 8 for the numerator, then 10 minus 8 is a 2. So 8 divided by 2, ideally have a 40. So our v is a 40. So that question is done for that case. We shall also look at another example. So you know, mathematics, we do a variety of practice. We know that we have to be speed and accurate, but all this is done through by the numerous practices you make. By the end of the day, you find that the numbers, you are used to such numbers. So make sure we make always practice. So let us look at example 7. Given that s equals to ut plus a half at squared. So here they want us to make t the subject of the formula. Take note, they want us to make t the subject of the formula for this case, but there is one t which has a degree 2. Is it okay? There are two t's, but one of the t has degree 2 and another degree 1. So we should take note that this thing shall not be ideally be done as usual as we do the other ones. Otherwise, this one can easily be simplified by using the aspect of completing squares. We shall borrow the knowledge from quadratic equations and we shall use that aspect. We complete squares so that we shall make t the subject of the formula. So for this case, let us make t the subject of the formula. How? We have said we shall use the knowledge of completing square. We shall use the knowledge of completing squares. So I'm taking this quadratic equation to be in the form or to be in terms of t. So I shall arrange the quadratic equation in terms of t. You remember, any quadratic equation is in the form of ax squared plus bx plus c equals to a 0. So for this case, this quadratic equation is in terms of what? In terms of x, because x is degree 2, we go to degree 1, and here degree 0. So that's how the quadratic equation will look like. So for this case, the above quadratic equation, you can ideally see it is in terms of t. So we shall use completing squares. You remember, when you're completing squares, or is this constant is put this side. So for this case, it is okay. I'll just have to translate this, and I maybe put it on my left. So solution, how shall I deal with this? So I'm just going to simply just put what is on the right. I've not changed anything, so I'll just begin with what is on the right. I put it to my left, but I'm putting it in terms of a quadratic equation which begins with degree 2. So I'll just put my finger, I arrange it as I have a t squared, is it okay, plus ut, I've begun with this side, equals to s. So I want to remove now the aspect of the denominator. How shall I remove the aspect of the denominator, which is a 2? I'll multiply throughout by 2. So multiplying this by 2, I'll have the 2 cancelling out with this 2. I remain with the a. If I multiply by 2, the 2 cancels out with this 2. I remain with the at squared. I multiply this also by 2. I remain with the 2ut. I multiply this by 2. I remain with the 2s. So I've eliminated the denominator. But you remember, this quadratic equation is in terms of t. And when we are completing squares, we make sure that this coefficient on the degree 2 is a 1. So by all means, I'll have to divide it throughout by a, so that I make sure that the coefficient on t squared is 1. So I divide it. So that's how we complete squares. We make sure that this constant is on the right, is standing independent also. So we have it. This is our constant now, which does not contain t. It is standing on this side. So from there, I make sure that this a is also what? The coefficient on t squared is a 1. So divide by a throughout. So plus 2ut. I also divide by a, equals to 2s. I also divide it by a. So we shall find out that this a cancels out with the a. We remain with the t squared plus 2ut over a equals to 2s over a. So from that step, we shall make sure, you remember, this quadratic equation is in terms of t. So this coefficient, what will be the coefficient of t? So all this is the coefficient of t. So here, all this is the coefficient of t. So in other words, this is the position of the sum in the quadratic equation. So that is our coefficient. So looking at that sum, and we obtain the coefficient, which is 2u over a. We shall get that coefficient, which is 2u over a. We multiply it by a half, and we square the answer we get. So our coefficient is 2u over a. I multiply it by a half, which this is our coefficient on t. And after the answer I get, I have to square. I will square that answer. So when I multiply by a half, the 2 and 2 go. I remain with the u over a. Remember, we say the answer we get, we square it. And after squaring it, we shall add it on both sides. So this is what we call completing squares. So t squared plus, maintain this the way it is, 2ut over a, then plus the answer we got. You remember we said the coefficient here is multiplied by a half. The answer we get, we square it, then we add it both sides. So plus u over a. Remember we have squared it, so this will equal to also 2s over a. We also add our u over a. You remember it is also squared. So looking at this square and this square, we shall consider t. Then we take the first sign here, which is a positive. Then u over a. We just square all of them at once. My brothers, if you expand this, you shall come back to this. You can try it in your free time. If you expand what we have here, you will come back to this. So this will equal to, this is 2s over a plus, square this, we get u squared over a squared. Remember the square will square what is up and also square what is down. So after having that, you remember for us to make, this is the t we are looking for, but it is still bound by the squared. So for us to unbound it, we shall make sure we put a square root on both sides. Okay, but we can further simplify this by getting the LCM. So looking critical at this, we know that the LCM will be ideally a squared. For those who don't know, you can take a squared and a. Get their LCM, divide by a, you get a, here you get 1, divide by a, 1, 1. So the LCM will be a times a, which is our a squared. So a squared divides this, we get a. One of the a will cancel out, we get a squared divided by a, we get a. The a we get, we multiply it times what is up. So we get 2a s. The a squared divided by this, we get 1. 1 times what is up, it is u squared. So plus our u squared. You remember here, this is still t plus u over a, but it is still bound in a square. So we said for us to move the square on both sides, we shall get a square root. Even here we get a square root, but a square root, the result is either positive or negative. So here simply the square will cancel out with the square root. We remain with the t plus u over a. This will equal to plus or minus root of 2as plus u squared over a squared. So from there we can easily make t the subject of the formula by simply shifting this thing, the whole of this, we shall shift it, we put it on this other side. Since it is a positive, when it crosses the equal sign becomes a negative. So we shall have our t will equal to, this will shift from here and come here. So it will be now a negative u over a, which is okay, plus or minus. Looking critically up, we cannot get the square root. So that as the result we have up will remain in the square root, 2as plus u squared, because of this operation sign. So we cannot get the square root of what is up, but here down is only a squared, and the square root of a squared is a. So from our knowledge, when numbers have the same denominator, we maintain it. Then we deal with the numerators. So we shall maintain a as our denominator. Finally, we have made t the subject of the formula. So our t, looking critically, our t here will equal to, said we maintain our denominator as a, which is that, because they have the same denominator. Then we say we have maintained that denominator. Then negative u will remain the way it is, which is okay, plus or minus root of, I can begin with that which is squared. So I can begin with the u squared, then I say plus 2 a s. So finally I've made t the subject of the formula. In case they give you to substitute in, just substitute in. So that is it. I've come up with that finally with that.